Alright, this video covers review 13 over factoring. So they are asking us the whole front page is to factor these polynomials. So problem 1, if we want to factor, we can see that this is a difference of squares because it has the x squared term and no x term. And when I take the square root of 256, I get 16. So that tells me I need to take the square root of x squared, and I would get x. With a difference of squares, the formula tells us that we make one positive and one negative. Keep in mind, you can also solve this one with the box. I'm not going to do it on here because we'll have plenty of examples with the box, but you can use the box to figure that out as well. Make sure that one factor is positive and one is negative. Problem 2 is the same thing. I can take the square root of 81a squared and get 9a. I can take the square root of 144b squared and get 12b. I would make one positive and one negative. Notice that the a is in front and it's my first term in my factors. B is in the back and it's the back term in my factors. So all you do is take the square root, keep them in the same order, make one positive and one negative. Problem 3 is a perfect square trinomial. This was the example we did on the second day where you take the square root of the back number and you follow the sign from the middle number. And again, if you don't remember any of these rules or formulas, or if you're like, oh, that's kind of like a shortcut, but I don't remember it, you can still use the box on every single one of these and get the same answer. But for this, we're going to have x minus 10 squared as our answer. So we take the square root of 100 and get 10. The sign tells us it's going to be a minus and it's going to be squared. And again, if you don't believe me or you don't remember this, use the box. Problem 4, we have a GCF. So I can take out a 3, x squared plus 10x plus, 25. From here, I can take the square root of the last term, which is a 5. The middle term is 2 times 5 and is a positive. So my answer is going to be the GCF of 3 and then x plus 5 squared. And again, you can use the box to do this if you don't remember the shortcut or the formula. Problem 5, we have a 2x squared plus 11x plus 15. There are no GCFs in this one. I can't take the square root of 15 nicely, and there is an x term, so I go straight to the box. I put my x squared term, my first term, and my last term. This one is a 2x squared, so make sure you put the 2 in there. And then the 15. My product is 2x squared times 15, so 30x squared. My sum is that middle number of 11. In my calculator, I put in y equals 30 divided by x and go to the table. Remember, while using the table, I am looking for two numbers, an x and a y, that are across from each other that would add to 11. Numbers like 5 plus 6 would add to 11. So these numbers come from my calculator, and I put exactly what I'm seeing from the calculator in the box. I'm seeing a positive 5x and a positive 5 and a positive 6, so that's exactly what I write. From here, I take out my GCFs, so 2x squared and 6x share a 2 and an x. 5x and 15 share a 5. 2x squared and 5x do not share any numbers, but they do share an x. 6x plus 15 shares a 3. Remember that as a quick check, you can do this number times this or that term times that to make sure this works, and this times this to make sure that works. Now, obviously, we can check everything, like refill the whole box, or maybe like I have some students on a separate sheet of paper, take 2x plus 5 and x plus 3, start on the outside of the box and work their way back in to double check their work, which is totally fine. But keep in mind that quick check will give you a generic sense if you're running out of time if you're doing it correctly. Problem 6, we have 10x squared plus 29x minus 21. So this is kind of some big numbers here, so I'm going to double check. 10 is 2 and 5. 21 is 3 and 7, so there's nothing I can take out of both of those, which tells me that I'm not going to have a GCF and need to go straight to my box. And again, I can't take the square root of 21, so it's not going to be a perfect square or difference of squares. So first term times last term, my product is negative 210x squared. My sum is 29x. So I put negative 210 into y equals. So negative 210 divided by x. And look at the table. And I'm looking for two numbers that will add to 29. Remember that you can skip over decimals. I'm only looking at whole numbers. Okay, so I'm seeing 6 and negative 35 get me to negative 29, but I need a positive, which tells me that it's going to be the opposite signs. So like 35 and negative 6, or 35 minus 6, which is 29. So from my box, I got a positive 35 and a minus 6. So I take out my GCFs. X squared and negative 6x share a 2 and an x. 35x and negative 21 share a 7. 10x squared and 35x share a 5x. Negative 6x and negative 21 share a negative 3. So my answer is 2x plus 7 and 5x minus 3. Problem 7. I have 3x cubed minus 21x squared plus 10x. So I can see that all of these have an extra x that I can take out. It looks like the first two terms I can take out of 3, but I can't take 3 out of 10. So I have to leave my numbers alone and just take out the x. Remember that your x's get 1, or you subtract your exponents. And then if you have x divided by x, it cancels. So from here, I'm going to take what's in parentheses and put it in my box. So my product is going to be 3x squared times 10, so 30x squared. My sum is a negative 21x. So I put 30 in y equals. And look for two numbers that add to a negative 21. I know that in order to add to a negative, if I'm looking at these, I need to look at my negatives. So still looking for negative 21. Remember, you can skip over anything with the decimal. Now, once I get back to negative 30, this tells me that I've gone all the way I can go, and there's nothing else that I can do to this problem. Now, this problem is possible because I took out a GCF, but I can't break the parentheses down any further. Problem 8, 2x squared plus 33x plus 18. These are not all even, so I can't take that 2 out, so I go straight to the box. I have 2x squared and plus 18. So my product is a 36x squared. My sum is 33x. So I put 36 into y equals. And I'm looking for two numbers that will add to 33. Remember that we skip anything with a decimal. Looking for two numbers that add to 33. And once I get to 36, I can say that I've thoroughly checked everything. And this one is not possible. So remember, this is an option. If you've gone all the way to the positives and all the way to the negatives and you can't find anything to this number, it is not possible. Make sure that when you're looking at your table, you look at your x's and you look all the way to this positive. If you have a negative in here, or if you're not sure, you want to just double check, you can go all the way to the negatives as well. I can guarantee that there's nothing in the negatives that would do anything to that. So problem 9, I can see that I can take a 3 out of all of these terms. From here, I use what's in parentheses and go to the box, x squared plus 8. I'm looking for two terms that will multiply to 8 and add to 6. So once you put them in the calculator, you will come up with 4x and 2x. I take out my like terms, so x and 4, x and 2. So my answer is the GCF and my 2 factors. Remember that factoring out that GCF is still part of your answer. Problem 10, I do not have any GCF, so I go straight to the box. 6x squared plus 4. So my product is 24x squared. My sum is negative 11x. So in y equals, I put negative 24 divided by x, and look at the table. I'm looking for two numbers that add to a negative 11. I'm sorry, the 24 is not negative. Two numbers that add to negative 11. Now, in order to add to a negative, I can see I'm going to have to look in the negatives. Negative 3 and negative 8 add to negative 11. So negative 3 and negative 8. Take out my GCFs. So those share 2x. And these do not share anything, so they really just share a 1. And it's a minus because my factor is negative. 6x squared and negative 3x share 3x. Negative 8x and 4 share a negative 4. And again, it's negative because of that last term, or the term I got out of the calculator. So 2x minus 1, 3x minus 4 are my answers, my factors. Problem 11, I can see all of these are divisible by 5, so I'm going to take out that GCF, and I have an x squared minus 10x plus 24. From here, I take what's in parentheses and go to my box. So my product is 24x squared. My sum is negative 10x. Negative 4x and negative 6x are the two numbers that you will get from the calculator that will multiply to a positive and add to a negative. From here, I take out my GCFs. These share a minus 4 and a minus 6. So my answer is the GCF of 5, x minus 4, x minus 6. Problem 12. X squared plus 13x plus 30, no GCF, so I go straight to my box. My product is 30x squared. My sum is 13x. When you put 30 into y equals and look at your table, you can see a 10x and a 3x. I take out my GCFs. And I'm left with x plus 10 and x plus 3. Problem 13 asks which expression is a factor of x squared plus x minus 6. So I'm going to use the box to figure out my factors. So my sum is x, my product is negative 6x squared. So negative 6 is 1 and 6, 3 and 2. In order to get x, I would need a positive 3 and a negative 2. Take out my GCF, x plus 3, x minus 2. So my factors are x plus 3 and x minus 2. The expression that is a factor is the only one that looks like whatever's in my parentheses. So in this case, x plus 2, that's the only option. 14 asks us which of these is which expression is a factor of 18x squared minus 15x plus 2. We don't have any GCFs, so we go straight to the box. 18x squared plus 2. Multiply for my product of 36x squared. My sum is negative 15x. This can be achieved by negative 9x and negative 12x and negative 3x. Those two added together would give us negative 15, and they would multiply to a positive 36. So we take out our like factors, 3x and negative 2, and then 6x and a negative 1. So my factors are 3x minus 2 and 6x minus 1. A is the only one that looks like that. Now for some quick review. 15 asks us to write a function in slope-intercept form that represents a line that contains the point -1/2 and 2 and has a slope of 6. So remember we use point-slope form. Y minus my y point equals mx minus my x point. And remember that you write your points with the opposite signs. From here I try to get y by itself, so 6 times x is 6x. 6 times 1/2 is 3. I add 2 to both sides because I'm only adding a number. I can only combine it with my numbers. So y equals 6x plus 5 would be my equation in slope-intercept form. Problem 16 says the function s of d equals 13d plus 30 can be used to find s, the cost of renting a scooter for d days. Write a description for the rate of change. My rate of change is a fancy word for slope. It's whatever's on the inside with the letters, so in this case 13. S is the cost, so it's the cost $13 per d, which is day. So it's always whatever's on the outside per inside. 17 asks us to simplify, and we have some things with exponents. I'm going to take care of negatives first. Anything with a 0, remember, cancels. So x3 and z stay on the top. X to the 4th is not happy on the bottom. It's x to the -4. But when I bring it up to the top, it is satisfied. Y to the 6th is the only thing on the bottom. And then y to the 7th doesn't like being on top, so we're moving it to the bottom. So break it up one at a time. 5 divided by 25 is the same thing as 1/5. With my x's, I have x cubed and x to the 4th, both on the top. Because they're both on the top, I add them for a total of 7. My y's are on the bottom. I have y to the 6th and y to the 7th. I add them for a total of 13. And then I just have one z on the top, which will not change. So my final answer is 1/5. My x's are on the top, and my z's are on the top. My y's are on the bottom. 18 asks us to identify the range for the graph to the right. So remember that your range is your y value, so bottom to top. On the bottom, down here, because my y's go up and down, the bottom goes on forever and ever and ever, and the top stops at 2. So 2 is my maximum, and it goes lower and lower and lower and lower and lower. So my y is getting less than, or could also equal, because there's a value there, 2. 19 asks me for a standard equation for the graph to the right. So first I'm going to write it in slope-intercept and then solve. So I start down at a -3, and then I go up 1/2, up 1/2, up 1/2. So my slope is 1/2. Remember that standard form is ax plus by equals c, so x and y on the same side together. So I move the 1/2 x to the other side, so x and y can be together. And then standard form cannot have any fractions, so I multiply by a -2. You could multiply by a +2, but all of your answer choices will have x's as positive, so that's what we're going to aim for. Remember, when you do it with your x's, it cancels. -2 times y is -2y, and -3 times -2 is a +6. Problem 20 asks us to simplify the following expression. So I distribute -2 times x, -2 times -6, 3x times x, and 3x times -9. Remember, when we distribute, we're multiplying. In order to get my final answer, I can't have any repeats. I have 3x squareds and nothing to change that. -27x's and -2x's is a total of -29x's, and then a +12 that is not changeable as well. Last page, Tanika's trying to find the area of her room to get a new carpet. Her carpet has a length of 3x plus 5 and a width of 2x minus 3. Find the area she will need to cover her floor. In order to find area, we will multiply. Anytime we are multiplying two factors, we have to use the box. So 3x plus 5, 2x minus 3. Remember to fill in the box, we multiply top times side. So 3x times 2x is 6x squared. 5 times 2x is 10x. 3x times negative 3 is negative 9x, and 5 times negative 3 is negative 15. Combine my x's, 10x's minus 9x's is 1x, so my total answer is 6x squared plus x minus 15. Problem 22 gives us the perimeter of a triangle, two sides, and asks for the missing side. So the first thing I'm going to do is find the total for the two sides. For the two sides, I have a 7x cubed and no more x cubes. I have a 3x squared and no other x squareds. I have a 6x and an x for a total of 7x's. And then I have a plus 2 for my numbers. In order to find the missing side, I'm going to take the perimeter and subtract, the two sides. So my perimeter is 7x cubed plus 4x squared minus 9x plus 3. And I'm going to subtract 7x cubed plus 3x squared plus 7x plus 2. Because I'm subtracting, I'm going to distribute that subtraction sign to make sure that I fully subtract every piece. So remember, anything that follows the subtraction sign in parentheses changes signs. Everything in front stays the same. And then I combine my like terms. So 7x cubes minus 7x cubes is 0x cubes. Those cancel. 4x squareds minus 3x squareds is a total of 1x squared. Negative 9x minus 7x is negative 16x. And 3 minus 2 is 1. 23 asks us for a table that is an example of direct variation. Remember, direct variation means you have no y-intercept. So like the point 0, 0 would need to be on the table. Anything else doesn't matter. You can make up whatever you want to go here. Sorry, my handwriting's really ugly with this pen. This part doesn't matter. This in a table is the way that you know it's an example of direct variation. Problem 24, ask for a graph that has an x-intercept of negative 8 and a y-intercept of negative 2. So I'm going to put those on the graph and then connect them. So x-intercept of negative 8 means it crosses the x-axis at negative 8. Y-intercept of negative 2 means it crosses the y-axis at negative 2. And then I connect a line between them, and that would be my graph that has an x-intercept of negative 8 and a y-intercept of negative 2.